Hello and welcome to Oxboon, the technical magazine with Wolfgang Rudolph. Hello and welcome today. I would like to show you something that has gone deep into our lives that it is not possible to imagine without. Electricity, devices with which we measure electricity. What color is electricity? One or two of you know it from the TV advertising. Red, green or whatever is all nonsense. Electricity hasn't got any color, electricity is invisible. We can't feel electricity. Okay, if it is strong enough, something can happen. But we can't say, okay, let's measure how much electricity is there. That's why we need extension of our senses as measuring devices. And measuring devices, that's what they looked like in the past. Here, for example, I built a measuring device, and with this I could measure my infrared rays. There's a solar cell in it, like you have on today on your roof. It turns electricity around, and the moving coil measuring instrument, what is in there, shows the results. That was the first moving coil measurement instrument. We have opened one, so to say broken one, and inside you can see a small coil with a magnet core, and there's a spring in it that sets it to zero always. But as soon as the electricity flows through it, it turns. Coil measuring instrument, I can read how much electricity runs through it and how high the voltage is. This was also available as a multimeter, the dream of my youth. Till I could afford one, that's how they used to look like. Today look different, have to look different, because we have different jobs to do. We have everywhere electricity. Where we have to judge the curve form, what does it look like, what do the bits look like, to go through a computer, through the internet whiz, rapidly as mad. We have to show these short happenings, stretch a little to show, so that you can imagine what electricity is. I say okay that our pressure waves are recorded from the microphone, but at the latest in the microphone it is turned into electricity, which is then strengthened. Just watch, I will show you now what electricity looks like, not red or green. Hello, this is a test, we want to see what happens. So now we stop it, I want to enlarge that here, I want to fit it in properly. I'll start it now. Okay, and now I will take this area on the left, this hello, and enlarge it. So, and now that is this hello. And as you can see, it looks pretty strange. And if I enlarge it even more, then we can easily see that there are simple curves. And that's what this electricity looks like. And as you saw, there are different highs and lows and thickness and so forth, and frequencies and voltages, something like that you can't measure with this device. How would you present the wriggling pointer to see if everything is okay? Is something wrong in a radio, MPIP drive player? Is anything wrong there? With this device it is impossible. We need the other devices for this. And these devices I've had a look at, and these I want to show you. From PCE UT 81B I have here. I would normally say an old bone, but it's a brand new device. But this series is old, all technicians know them. It is the standard device of all. It has a big 160 x 160 LCD display, pixel big naturally, and we look at it, it is backlighted. That doesn't mean much to the camera, but in dark corners it is good to read. At the moment it is in the DC voltage and auto range. That means it chooses its own voltage area. And when I put it here onto my 9-volt battery, and you look at the display, I'll tip it up so you can see it better. When idling, this battery has a 9.60 volt, and that is the normal standard value. So that is not special. I have here though soft keys, keys that have special assignments, measuring area or measuring value changed. When I push here, then the alternative current is shown. So I can now measure alternate currents. And the exciting thing is that it's not only a multimeter for electricity, voltage, resistance, diode tests, frequency, capacity measurement, but also, with a push of a key, it becomes an oscilloscope. Now you can see my graphic display, and now I will hang my Oscar tester on it. Set test heads and the such, give a triangle signal, put them into here. So now I can turn it on. Takes a little time and automatically the amps and the time bases be chosen. And as you can see, we have a nice clean signal. At the top we have chosen 1 volt and 500 microseconds. When I change it now from 1 kHz to 10 kHz, it only takes 1 moment. 50 milliseconds. I can also go on to 100 kHz. Now we are by 5 microseconds. Now more we have a broadband of 8 MHz and 50 megasamples per second. Totally sufficient for lots of service areas, television repair or computers. If you want to do something in your car, that is the robust digital device for this at the moment. The price category is around 250 euros. Delivered with it is the bag, the AC adapter, the connection cable for the computer, also optical isolator so electricity can go through it to the computer. The measuring cables is normal and the handbook normal, and this software shows everything what is on the display of the device. You can record all the data that are recorded to use later or to export for a spreadsheet. You can also, on the display itself, the device values 10 different displays itself, saves things, and later call them up to see how was it, how did it look like. A standard device that everyone needs. The SDS 1022DL from PCE. This oscilloscope would have brought you here for you, would have been for 30 years for this price unthinkable. It would have been a dream of everyone, someone like this to own. And now I have worked with it for 14 days, a device that is definitely under the 250 euro class. Look at it, TFT display, 2-channel oscilloscope, full digital 8-bit resolution. It has a broadband from 25 MHz, 500 megasamples per second, and normally that's enough for all your service areas. We're not working with too high frequencies. It is totally adequate. We have the normal control elements here. Here the amplitude for channel 1 and channel 2. Here we have the time bases. You don't need all that normally. It works on its own. And I've brought something here on my recorder. Babble from here. Now when I attach it here, you can see that it starts straight away. And it can record all that. And we also have the possibility, the stop mode. Now we have stop now. We can still later see what is the resolution, how does it look, even change the amplitude. We can save the data onto the computer too, onto a USB stick. There's so many possibilities that we can analyze our signal later. At the moment you only see 1 channel, but naturally it has 2 channels, which I can make visible. At the moment there is none. There's only a thin yellow line. We can also, with both channels, add or subtract, divide. We have a FFT transformer in it. That means I can really take the signal apart. I have many menus, which you must first learn. I have a serial interface on this device. It is nice, little, light, and for all things, light to use. A service oscilloscope from the best, for a price, well for me, was a surprise. A good device. There it is now, the dream of my sleepless nights. From PCE the DSO 5202B, a digital memory oscilloscope. And behind this device there's an oscilloscope with a broadband of 200 MHz, 1 gigasample per second. That is pretty massive. And with this device you can do absolutely everything for what you need today on measuring technique. It is a double beam oscilloscope, a sort of art that really thrills me. You don't really need instructions when you know how a thing like this works. And when we look at it on the controls, we have different colors here: green, red, blue, and so forth. And this assignment we have here, each different channel has the color assignment. And I can look at the color and know where I have to touch, and which I have to push, which is the right channel, which is the right button, a wonderful and simple thing. It can naturally do all mathematical functions, all the channels add, subtract and divide, FFT and interpoling, and all important settings happen automatically.
Verknüpfung der beiden Kanäle, Addition, Subtraktion, Multiplikation, Division, FFT und Interpolation geht natürlich damit. Und alle Einstellungen, alle wichtigen, funktionieren auch automatisch, wie bei den meisten digitalen Speicheroscilloskopen heutzutage.
I also have the possibility to send my results over to the USB stick or a printer, and naturally attached to a computer. It is delivered with 2 probes, they are with it, and naturally you could start getting excited about it, lots of menus, but everything is described in the display. And you only need to read it and know which button to press, which is normal nowadays. 200 megahertz, I wanted to look how clean the oscilloscope does that. I've brought a paper clip with me, to stick it into here. To show all the functions it is not enough. I brought a transceiver with me and it stands there at 145 mm. That means by transmitting it goes to 145 to 100. Now I could hold the transceiver here next to the paper clip, and near the top you can see I have a really clean line. And down here it is shown 145 to 100, so that thing works. In 2 meter band good. I've also had signals of up to 300 MHz, so stable it is, but I'm not allowed to send that high. I haven't done it. I have a very nice device, a dream come true, and I think you should simply have a look at it. The data bank, have a look at it. For those who need it, that is my choice. So we are at the end now, at the end of the cast that I enjoyed, and when I had to think which of these devices I would like to have, this one I have a great-granddad, and it still works. A stable piece, this here, a nice device, had no restrictions, nothing but is here. Okay, this is a dream. I think this will be my big love. I hope you have lots of fun working, and working with these devices makes fun. I wish you all the best. Until next time, and bye.